Hello friends, this is Praveen. Today we are going to learn about the rational numbers. So first let's start with the basics. In earlier classes we have learned about the natural numbers, whole numbers and the integers. So let's give it a shot. So first, if I have a basket in which I have 3 apples and 2 oranges, total 5 fruits. So how do I represent it on a number line? So it would have 1, 2, 3, 4, 5, 6, 7 up to the positive infinity. These numbers are known as natural numbers or the counting numbers. What if now I have to represent what is left in a basket after taking all the fruits out? It would be 0, but 0 is not included into that. So I include or add 0 to this set of numbers and I get the whole numbers. And now take another scenario in which I own a loan from a bank. Now I have a money, but it's not mine, that is it's negative. So if I add the negative numbers to the set of whole numbers, I get the negative numbers. These include -1, -2, -3, -4, -5 up to the negative infinity. Are all the numbers finished now? No, they aren't. If I have an apple, I eat it half. Now, how would I represent it? What is left? It would be between 0 and 1, but it is not 0 or neither 1. So, it would be between the 0, that is 0.5. This is known as rational numbers. So, how many rational numbers are there? There are infinite rational numbers. So, 1 is also a rational number. I will tell you why it is also a rational number. And any number, when we divide the numbers, there could be infinite division of anything. So there are infinite type rational numbers between two rational numbers. And so first let's link between these numbers. So first we get the natural numbers. So this could be represented by n. Now if I add 0 to this group, we get a whole number. So all natural numbers are whole numbers, but not all whole numbers are natural numbers, because aspect 0 all the whole numbers are natural numbers. Then we have integers, that is represented by I, and after the integers we get the rational numbers. So all the integers are the rational numbers. So for the competitive approach, after the rational number, there is another set that is opposite to the rational number, that is classified as the irrational number, that is IR. And these both rational numbers and irrational numbers are together classified as a real number. And there is another set of the numbers which is opposite to the real numbers, that is called the imaginary numbers, that is denoted by IM. So this is the Venn diagram of how to get the link between all the numbers. So this helps to solve the questions like, are all the irrational numbers rational? Just like as you can see, they are both in separate group, they are. But all rational numbers are real numbers. So these types of questions can be solved using this Venn diagram. So now let's move to the properties. So now we have talked about the logical approach. Now let's move to the technical definition of the rational numbers. So properties we are going to learn about. So there is first property. We know that a rational number is between that is any two rational numbers. We will see why the integers are also a rational number. So it could be just like we take 2.5. So this could be written as a fraction, that is 2.5, in which I will take the 0 back, a point back, and here I will multiply by 10. So this is 25 by 10 So all rational number is nothing but a fraction that is written in the form of p by q, that is p divided by q, where q is not is equals to 0. Why not is equals to 0? Because if we take any number in the as a value of p, just like 3, and take the q as 0, it is indefinite. So now let's move why the 2 is also a rational number, or just like 1 is also a rational number. We can represent it in the form of p by q, just like we can take 1 as 1 by 1, that is 1. Here we satisfy the criteria that q is not is equals to 0. Here in the same way we can take 2 as 2 divided by 1, that is equals to 2. So every number that is integer is the rational number, as same as every natural and a whole number is also a rational number. So now let's move to the second property of the rational numbers, that is when if the it is a rational number when divided or multiplied. So first take then divide and multiply by a same number, it would be equals to p by q. Sorry, p m and qm. That would be, we know that we can simplify and cut this m and m, so we get p by q. This is known as the equatorial fraction. In this same case, we take the third case as p by q both divided by m. That would be, if we will reverse this or take a reciprocal, it would become multiplication. So p multiplied by m is equals to q multiplied by m. And now from this we can simplify this equation. Here we also get the p by q. So these two are equal to p divided by q. So we have completed the properties. Now we will move about to the comparison. So what is the comparison? Comparison is between two numbers, that which is bigger, which is smaller. So we would going to solve this in the two approaches, which first is the standard approach and second is a shortcut approach. So first let's start with the standard approach, in which it is useful when the more than two no, rational numbers are given. Just like let's say 1 by 2 and 1 by 3, 2 by 4 and 3 by 4. So what you have to do in a standard application, that is take the LCM of the denominators. So LCM is equals to 12. So we take 12, multiply it, we have to multiply 2 by 6 to get this. So multiply by 1 by 6 we get 6. Then multiply by 4 and 3 to get 12. Then multiply by 4 by this we get 4. Then multiply by 3 to get this, and multiply by same by 3, that is 6. And multiply by this to get 3, and multiply this by 3 we get 9. So this is the first fraction, this is the second fraction, this is the third fraction, and this is the fourth fraction. So let me take, that is 6 by 12 is the first fraction, that is 1 by 2, and then we have is 4 by 12, 6 by 12 and 9 by 12, in which no 9 by, we know that 9 by 12 is biggest, so we can take 9 by, that is 3 by 4 is the biggest among them, and the smallest is 4 by 12. In another cases, the question could be asked to arrange them in a ascending or a descending order. Simply you have to arrange the numbers, which we know LCM are the same, and we have to take consider the numerators of these numbers. So here we have is 3 by 4 is the biggest, then we have is 6 by 12 is equals to, here is 6 by 12, that is, here would be 2 by 4 and 1 by 2, that is 1 by 2 is equals to 2 by 4, which is then we have is, this is greater to, that is 1 by 3. So this is how we can arrange in a ascending order. So now let's move to the shortcut approach. So this is useful when mostly two terms of are given, because after two the terms or the calculation started getting complicated. So just example 1 by, we have to take 1 by 2 and 3 by 4, which is bigger. So we can simply take is, we have to do is cross multiplication, and which arrow should be facing upwards. So 2 multiplied by 3, e, that is 6, and the 6 will be in this side because the arrow is moving in this side, so we have 6, and 4 multiplied by 1, the arrow is moving in this side, so we get 4. We know that 6 is bigger than 4, so this that means 1 by 2 is smaller than 3 by 4. So this is how we can represent it. For you can also perform by with another number, that let's include 1 by 4 in that term. So we know that 3 by 4 is here and 1 by 2 is here. So this number could be take three positions. This is one position, this is second position, and this is the third position in the ascending. We are going in a ascending order. So we have to first compare with this fraction and compare with another with this fraction to get proper positions. So first let's consider with 3 by 4. So we do a cross multiplication. We got that is 4, 12 by 4. So this is bigger, means 3 by 4 is bigger. So this place is eliminated for the 1 by 3. 1 by 4. Now we have to consider compare 1 by 2 and 1 by 4. That is 1 by 2 and 1 by 4. We do cross multiplication, we get 2 and 4, means this is bigger, so 1 by 2 is bigger. So this place is also eliminated for the 1 by 4. So that is the 1 by 4 would be available here. So now we can arrange in ascending order. So this is a shortcut approach. As I told, when you will go with the high terms, they would start increasing. So now let's move to the operations. How we perform the different operations? We know there are 4 fundamental operations. These include addition, subtraction, multiplication, and division. So how we can perform if the numbers are given? Let's take with the addition. So addition, take two just like we have is 1 by 2 plus 2 by, let's take 6. Now how we will add it? It is same like adding fractions. So first we take the LCM of the denominators, that is 6 LCM, multiply by 3 to get this, multiply by 1 to get this. Same with the numerators, 3 multiply by 1, that is 3, and that is 2. Now there is plus symbol between them. Now we can add them, that is 5 by 6. So this is how we do addition. In the same way, if it is we can do for the subtraction. Let's take 5 by 6 and we are going to subtract 1 by 2. 1 by 2, in which first we have to take the same approach like the addition one. So let's take the LCM. LCM would be again 6, then multiply by 3 and multiply by 1. So we have to multiply it by 1 and multiply 3. So that is 5, and in which multiply by minus 3, that is 2 divided by 6, and for the simpler simplification we can take this as 1 by 3. So this is how we can do subtraction also. Now there is another story for the multiplication and the subtraction. Division. So now let's move to the multiplication. So by multiplication, if any number is given just like 12 by 13 multiplied by 3 by 4. So how we can do is, we have to simplify, multiply the numerators and multiply the denominators to get the term. In the same way, we will for the division also, we know that division, just like say let's take for the same example, 12 divided by 13 divided by whole divided by 3 by 4. We know that division is opposite of the multiplication. So we can take reverse it. We will see what the reversing of this is called sometime later. So reversing of this, we will reverse it, that is 4 by 3. Now it would become 12 by 3 multiplied by 4 by 3, and we have to then multiply by the denominator, numerators, as we have done in the multiplication case, and the same way we have to multiply the denominators to get the answer. So this is how we can perform the fundamental operations on the rational numbers. Now let's move to the different types of properties that a rational number follows. So for the properties, first let's learn about the closure property. What does the closure property states? A closure property states that if you take two numbers and perform any operation, that is addition, multiplication, division and multiplication, that should be in the range of the number that we have picked. Just like if you are picking a two natural numbers, the operation should be a natural number, then it will be closed under that property. In a commutative, it is the same way as a plus e is, we can take any operations here, so I am putting a blank or a circle here, is equals to b slash a. So in which we have to only reverse the number or move the numbers. So this is that. Then we have is associative property. Associative property states that you can move the numbers, move the brackets. So in this we usually include three numbers, that is a bracket, that is any symbol, b, then is any symbol, c. And it would be equals to, we can take that is a symbol, b symbol, c. So they should be equal, then it the number is associative. And the third main type of property is the distributive property. It says we can move the operations. We have moved the numbers, we have moved the brackets, now we can move the operations. So there are two types it is possible for, that is multiply by a and take b. So here it should be equals to a b, that is a multiplied by a, that is a square, and multiply by a. So there is any symbol, so here it would be become symbol, and a multiplied by b, that is ab. So these are the what the properties states. So now let us know that which numbers are closed under closure property, so commutative property and associative property, and as well as the distributive property. So let me make the table for it. So now we are going to learn about the closure property. So in one side we have is operations, that is plus, minus, multiplication and division, and on this side we have is the numbers. So we take the whole numbers, and then we will take the integers, and we are going to take about the rational numbers. Rational numbers, we are not taking the natural numbers because the natural numbers follow the same property as a whole number, because only a zero is added to that term. So now a whole number is closed under closure property, and all the numbers are closed under addition, and none of the numbers are closed under the closure property other than the integers and the rational number, that is the whole numbers, and the natural numbers do not follow the closure property under subtraction, and all the numbers are closed under the multiplication, that include natural numbers, whole numbers, integers and rational numbers. And the division, we know that none of the numbers follow the closure property of division. So this is how does our closure property looks. Now let's move to the next property. So next property we have is commutative. So we have a commutative property in which, let me erase. We have seen that a closure property only states about the set of numbers, but the associative property and commutative property doesn't state that. So it would be the same for, if it is the true for commutative, it would be for true for the associative. So it is include commutative and associative. So all the whole numbers are closed under addition of, that is commutative and associative, and all the subtraction it is not closed under neither commutative and neither associative, and it is then true for all multiplication for all the numbers, and then it is not possible for the division to follow that property. This is how this commutative and associative works. Now to move to the distributive property first, to move towards the distributive property first, let's take about the additive, learn about the some few terms. The first term is additive identity, and this is also for the subtraction also. So what is the identity? Additive identity states that if you multiply a number, that is additive identity states that what number should you add to get the same number. That is a plus what number you will add to get a again. That is simply 0. And in the same way, in the subtraction, it is which number should you subtract. That means minus which integer you take in minus, that is a, that will be there will be subtraction. So we get is again 0. So the additive and the subtractive identity is 0. So this is 0 and additive inverse. So what is the additive inverse? We get a 0 here, which is identity inverse. So if we take it here, that is 0 here. So let me take a plus 0 is equals to a. Now if I take it 0 there, it becomes minus 0, that means simply a 0, and bring it here, that is plus here, it will become minus. So a minus a, that is equals to 0. So what should you add with the number to get it 0? We will have simply need a minus symbol. So additive inverse of 1 by 2 is minus 1 by 2. In the same way, additive inverse of minus 101 divided by 101 is simply plus 101. So additive inverse of the positive number is negative, and for the negative numbers it is positive. And in the same way, subtraction, we have seen the only, if it is subtraction, it would move with the positive. So, and now we have some multiplicative identity. Multiplicative identity, in the same way, what should we multiply to a number to get the same number back? That is, if we have is 1 by 101, so what should we multiply it to get the same number back? That is 1 divided by 101, that is simply 1. So as it is for subtraction also, and it is also for the division. And so in this division, so what should we divide with? 101 to get 101. Simply it would be divided by 1 to get the same number. So this is, what is the multiplicative inverse? So multiplicative inverse is you should multiply, what should you multiply with the number to get it 1. That is the number itself, that would become a square. But it would be not the number itself, but it would become 1 by a. So it would become 1, that is a by a, and it would become 1. This is the multiplicative inverse, that is flipping the number. In the previous term, we'll know, I will tell about the flipping terms. This is called the reciprocal of the number. And same way for the division, it would be 1 divided by what is equals to, again 1, that is it would be a by 1. So it is divided here, so it would become a multiplied by 1 by a, and it would become 1. So now add a multiplicative inverse. So what is the multiplicative inverse? That is, what should you we know, we have learned this, that what should you multiply by the term to get 1. So now let's learn about the distributive property. What is the distributive property states that is, if we have is a and we have is number b and c inside, so it should be equals to o. Let's prove it. So if a number is multiplied by b, we get a b, and then a same number is multiplied with the bracket, we will get this number same would come here directly, and if you multiply a by c, we get ac. And there are mainly two operations present here, that is addition and subtraction. So if a question is given that one it is 1 divided by 2 bracket 3 by 4 bracket, that is plus, or we can take a subtraction here and take 1 by 4. So simply you can do is add them and multiply them, but you can also do is that first you multiply these terms and then multiply by this and then add both of them. If there is a subtraction between them, you have to subtract the multiplicative or the multiply the a by 1 by 2 and 3 by 4, and then subtract it from 1 by 2 multiply by 1 by 4. So it is distributive property is applicable for the addition and the subtraction. Now how do we plot the numbers on a number line? So plotting a number on a number line is an easy job. So this is the number in which it includes 0, 1, that is -1, and -2 here, 1 here, and -2 here. Sorry, it would be plus in this side. So how we can place a number? If just like 0.58 is given, we know we have to first convert into the fraction to it. So we get 1 by 2. So we have to take the two parts of the first part and then take this first part of it. We have divided this part into one part and we get this part. So this is 0.5. In the same way, if it would be the minus 0.5, it would be available in the another side of that is 0.55. Now what if it is not given in a mixed fraction, it is given as 3 by 2? How we would plot it? That is simply we can take as a convert into the mixed fraction, that is 1 and 1 by 2. So we know that it belongs after 1 because it is more than 1 and it is half. So we have to take this proportion as a half and plot it, that this is equals to 3 by 2. So here you can do in a positive on the positive scale also and for the negative scale also. So this is how we place the numbers on the number line. Now if the two numbers are given, how we can find out if they ask that is find the 10 numbers between that, how we can find out? It would be easy if it is a natural number, just like a number between name any three numbers between 12 and 20, then you can easily write 13, 14 and 15. These are the three rational numbers. Natural numbers, you can say whole numbers or the integers. So but if the rational numbers length became smaller, so how would you, if they say find the rational number between 1 and 1 by 13, that is between 12 and 13, three rational numbers, you have can find out by two methods. That is, one method by taking the dividing these numbers. So we take the number and divide it by 2. Add both numbers and divide it by 2, we get 12.5. That is also between that. And now you can divide, take the sum of these, that is 12 and 12.5, and you will get a number here, that is 12.25. And now you can divide further and further to get numbers. Or you can simply take the 12.5 plus 13 divided by 2, that is 12.75. You can take the numbers like that way. Sometimes easiest shortcut approach is to be convert this into the fraction, both into the fraction. So we get the 12 as 12 by 1 and 13 by 1. So we can take convert into it, multiply by 12 here and multiply by 12 here. So 144 divided by 12. So we can take one in the same way. We have to take it equatorial fraction, that is multiply by, let's take, if you multiply by 12 here, so 12 and 12 here. Now just like if the number would be, the between the number would be 145 divided by 12, then you can take 146 divided by 12 and 147 divided by 12. And if the number is divisible by the denominators, you can simply divide it to get the required answer. So let's summarize what we have learned today. First, we learned about the laying anchor between all the different types of the numbers. Then we learn about which type of properties they follow, just like what is the technical definitions of the rational numbers. Then we learn about how to compare these rational numbers when the two or more type of is are present by the two methods, the shortcut method and the standard method. Then we learn about how to perform operations if few operations are given. And then we learn about the properties that they follow, that is closure property, commutative property, associative property and the distributive property. And we learn about the few more terms, that is additive identity, additive inversion, then additive identity, multiplicative identity and multiplicative inverse. Then we learn about how to place the rational numbers on a number line, and as well as how to find the rational numbers between two number lines. So friends, at the last, thanks for watching.